Here's another example for our multiplication rule when we have independent events. Suppose that a company selects two people who work independently inspecting 2x4 timbers. Their job is to identify low-quality timbers. Suppose the probability that an inspector does not identify low-quality timber is 0.2. What is the probability that both inspectors do not identify a low-quality timber? So to begin with, the probability we were given in the problem says that the probability that an inspector does not identify low-quality timber is 0.2. So probability of not identifying or no identifying is 0.2. The question we want to know, what is the probability that both inspectors do not identify low-quality timbers? So what is the probability that not identifying or no identifying for the first inspector and not identify for the second inspector? Remember, when we say the word and in our probability, we're implying multiplication for a rule. So this says that there is a 0.2 probability for the first person not identifying, and then 0.2 for the second person not identifying. Multiply those two numbers together on your calculator and you end up with 0.04 or 4%. There's a 4% chance that both inspectors will not identify or miss low-quality timber. The second part of this question is a little bit more of something that you could almost just play around with. How many inspectors should be hired to keep the probability of not identifying low-quality timber below 1%? So how many would they have to hire to keep it below 1%? Currently, they're at 4% with 2 inspectors. What if we say we're not identifying, right? And we are currently at 2 inspectors. What happens if we just add another inspector on here? What if we just include the probability of 3 inspectors missing or not identifying the low quality timber? Well, just multiplying one extra person into this problem of 0.2 probability for each one of them missing ends up being 0.008. If I change that to a percent, that's 0.8%. So at less than 1%, it's a less than 1% chance if I have 3 inspectors that they will not identify low quality timber. So this is a good example also where this particular, let's say, company set the unusualness bar. Instead of us using the 5% as being the cutoff for something that's usual versus unusual, this company wanted maybe to have better quality control and yet still be able to hire the minimum number of people to keep costs down. And so they identified quality control for this company, let's say, was they didn't want to miss more than 1% of the products they were selling, and identifying they didn't want to miss them because they were low quality. And so by just hiring one extra person, they're able to meet that threshold because it would be unusual for 3 inspectors at this company to miss that low quality timber or not identify that low quality timber.